This is 8-5, Law of Sines and Cosines. Let's take a look at the warm-up problem. So pause the video and try the warm-up, hit play when you're ready to see the answers. So there are your answers to the warm-up problems 1 and 2. So in this section, basically what we've done before, trigonometry, is we've been using right triangles all along. Now we're going to be looking at triangles that are not right triangles and being able to use trig ratios as well. So we can use the law of sines to solve a triangle if we have 2 angle measures in any side length, or if we have 2 side lengths and a non-included angle measure. This is our formula for law of sines. Sine of capital A, remember, is angle. So sine of angle A over its opposite side length A, as seen here. Sine of angle B over its opposite side length B equal to sine of angle C over its opposite side length. So let's see what that would look like. So notice in example 2A here, I am looking for side FG, so I can call that, let me explain first. So we have 2 angles and a side. I've got this angle right here, 39, and its opposite side, and then I have the angle 32 and the side opposite that we're trying to find. So I could call this lowercase f if I wanted to, and I could call the one we're trying to find lowercase h. And so what I can use is sine of angle 39 over its corresponding or opposite side length there, 40, is equal to my sine of my angle 32 over the h that we're trying to figure out, the side length FG basically. I can write it as FG as well, but I just wanted you to see based on the letters here, because we have sine A over A, sine B over B, etc. And then from there you see that we have a proportion. So that's all we need. We only need these 2 so that I can set up my proportion and solve. So I get 40 times sine 32 is equal to sine 39x, or if we want to call that FG. And so we'll be dividing sine 39 to solve. And so now I can just type this in my calculator and we'll get the length of FG. So we get that FG is equal to 33.7. So side lengths, it said to round to the nearest tenth, and angles to the nearest degree. Okay, and this next one, I see that I have 2 sides and a non-included angle. So I can call this my angle A if I want, and so the side opposite would be 8, so it would be sine 51 degrees over 8 is equal to, and then normally I have another angle, in this case Q, that we're looking for. So sine of angle Q over its opposite side length of 6. And now I can cross multiply. And so I get 6 times sine 51 equals 8 times sine of Q, divide by 8, divide by 8. And when I do that, we get that the measure of angle Q would be the inverse. It's going to be equal to sine -1 because we're missing the angle. Whenever we're missing an angle, we use that inverse sign. 6 sine 51 over 8. And the measure of angle Q, when you calculate that, should be rounded to the nearest whole for an angle measure, 36 degrees. If you're ready for the Now You Try, pause the video and hit play when you're ready to hear the explanation. Okay, so I'm noticing that I have my 2 angles and a side. And so I'm looking for side DF. You can call that lowercase e, I guess, since it's across from angle E. So I've got sine of 105 over 18 equal to across, we've got sine of 32 across from side DF, or you can call that lowercase c. So then I get sine of 105, c equals 18 times sine of 32. Divide both sides by sine of 105. Type this in your calculator and you will get C, or what we are calling DF. And it's about 9.9. So DF is about 9.9. Okay, in our next one, we've got our angle of 75 degrees, and we're looking for the measure of angle S, which across from 5. So that would be sine of 75 over 7 is equal to sine of an unknown angle. So I know I'm going to need inverse sine here. But sine of S over 5, don't want to mix up the S and the 5 there. Okay, and so cross multiply, we get sine 75 equals 7 sine S. Divide both sides by 7. And I'm going to take the inverse sine of that. Let me cancel that. So the measure of angle S is equal to sine -1. Where'd my 5? I missed my 5. I mixed in with the sine. Sorry, 5 sine 75 over 7. And when I do that, rounded to the whole degree, is going to be about 44 degrees. Okay, now for law of cosines. We can use law of cosines when we are provided, right here, when we have only the side lengths, so all the side lengths, or two side lengths with one of the included angle. Remember in law of sines it could not have the included angle. So that's when we use law of cosines. So law of cosines is a little bit more involved. As you can see, there's a lot of variables in here and it can be confusing for some people. So let's take a look at this using example 3. So in example 3, since I am missing xz, I'm missing that side, I'm going to call angle y angle A when I'm thinking about this, because I'm really just going to focus on this first formula. And I'm going to call the side length lowercase a. So as I'm plugging in here, and the others don't matter, I can call this one B and this one C, which means across from the B would be capital B, angle capital B, and across from the C would be angle capital C. Not really, we don't really need those, we need the sides. So let's take a look. This is our formula. A squared is equal to B squared plus C squared. Almost like the Pythagorean theorem there, right? Then it's minus 2BC cosine A. So I'm going to take my A squared, which we don't know. Leave that. My B squared is going to be 35 squared plus my C squared, which is 30 squared, minus 2 times B is 35 times C is 30 cosine of angle A. Well, I have the angle, so cosine of 110. Cosine of 110 degrees. Okay, and so I can calculate all of these. So I've got 35 squared. Oops. Okay, so we get A squared equals 1225 plus 900 minus 2100 cosine 110. So that's going to equal 1225 plus 900 cosine of 110 is negative 0.34. So negative 2100 times negative 0.34 approximately. Now this is multiplication, and it's going to change to a plus sign there. So A squared equals 1225 plus 900. The two negatives, negative times a negative is a 718.24. 718.24. So then I added those up. I got A squared equals 2,743.24. I took the square root of both sides to cancel the A squared, and I get the A equals 52.4. Now for example B, I'm looking for the measure of angle T. So measure of angle T. So I'm going to use side T as my starting point, as like the A squared. So I'll just call this A, That's capital A, and this is B, and this is C, because the B and the C don't matter, remember. Okay, so if I have A squared equals B squared plus C squared minus 2BC cosine A. So I have 7 squared equals 13 squared plus 11 squared minus 2 times B 13 times C 11 cosine of A. I'm missing the angle, so I know I'm going to need cosine -1 at some point here. Cosine, inverse cosine. So 7 squared, 49 equals 169 plus 121 minus 2 times 13 is 26 times 11 is 286 cosine A. So I can combine the 169 plus 121, which is 290. So 49 equals 290 negative 286 cosine A. I can, since I'm solving for cosine A here, I can subtract 290 from both sides. I get negative 241 equals negative 286 cosine A. Divide by negative 286, divide by negative 286. 241 divided by 286 equals 0.84. But remember, I need inverse cosine. So I'm doing cosine -1 of 0.84 approximately. So you should get about 32. We run around to the nearest degree, sorry, 33 degrees. So the measure of angle A is equal to measure of 33 degrees, actually measure of angle T. And now that I think about it, I should go back to my other problem. I said that A was equal to 52.4, but just keep in mind the question asked for XZ. So really XZ is 52.4. I'll go over this problem in class because the video is too long. We'll go over these word problems in class just to save time on the video.